Hello, my name is Anthony, and today's video is going to be slightly different in the sense that I'm going to talk about some of our sketches and some of the models that we're trying to build, and we'll talk about the electronics that will go inside the quadcopter. So yeah, let's get started. So generally, before I create a 3D model of any product, for a matter of fact, but in this particular case, the drone, I do make a couple of sketches, and this is not the only sketches I have. I mean, I have a sketch pad, and I try to basically design a drone that I kind of like, or at least have a general sense of how I want to design the drone. Now, when we're designing a drone, there are certain features that are important. For example, it needs to be completely autonomous, and it's going to use computer vision to solve this problem. We also wanted to have extended camera capabilities for high resolution image capturing or infrared capturing. So this is the idea of what I want to build. It's basically an elongated drone with a couple of cameras, mounted either on the what do you say, the edges of the motor, or they'll be cameras mounted on the top and on the bottom. Whereas, I mean, the configuration will be subject to change based on testing and figuring out what the actual orientation is. But the goal is for the drone to see in 360. So let's go to the 3D model. What we have over here. This is still not a complete picture, but it's the goal also is to make it look pretty, like an insect in that sense, because it does look like an insect, and also giving it the impression that it's a robot that is there to serve. I wanted to have the personality where it's I am here to serve you. I am autonomous. I am you give me a mission and I will be able to do it. I won't fail you. That's the kind of personality, that's the kind of look I'm looking for when I'm designing this particular drone. It's a pretty, I think it's coming out okay. I mean, it's not the best, it's clearly going to be iterated and completely changed in the future, but this is the, the first draft, if you want to call it. Yeah. All right, so let's go into what's really going to be inside this component on this particular drone, the electronics and how everything inside is going to work. So what I have over here is the block diagram of the Boxy drone. Now, the reason why I'm calling it the Boxy drone is because it's very box-like. And I've also created a small, little wooden prototype of it. It's still, it's wooden because it's easy to fabricate. But the goal is to create this small little wood prototype. If you can't see it, it's basically it's a wooden prototype. Basically, it's very it was easy for me to fabricate this and make this, so I just made it out of wood. This is very boxy in the sense it looks more like a cuboid. But anyway, so what's really going inside this particular drone? What's the high level configuration? What's the high level block diagram? So what we'll have is the flight controller, and the flight controller will do a couple of things. First and foremost, it'll be able to control the motors. Motor control is not an easy thing. It generally does take a lot of computing and resources. For example, you need to do the timing diagram. That you need to trigger the MOSFETs that spin the brushless DC motor, and it needs to get feedback. Get through back EMFs, and then again, start switching the MOSFETs so that the motor spins at a particular speed. So it's doing a lot of computation just to spin the motor. But on top of that, it'll also have the flight control, where it would be a PID or a model predictive control to stabilize the flight. So when you say fly high and you want it to be hovering, you don't want it to be you want it to be hovering. You don't want it to be unstable. Or when it's flying and there's external disturbance, maybe because there's more wind, you want it to be able to fly smoothly. So the flight controller will basically do a lot more computation, not just control the motor, but it'll also get sensor readings from the IMU, which is the image processing, not image processing unit. It's the inertial measurement unit, and it'll get readings from the accelerometer and the gyroscope. And based on the orientation that the sensors are giving you and the orientation that it needs to be in, it will do some computation. There'll be some sensor fusion algorithms, sensor filtering like Kalman filtering. And so you need a powerful processor just to do basic flight dynamics. I won't say basic, but just doing flight dynamics and motor control will be done through one processor. Sometimes you can, have 4 different microcontrollers to control each motor. A lot of hobby aircrafts, hobby ESCs, which you call them electronic speed controller, has this feature. Or, if you break apart the hobby electronics, you'll realize that they have 4 MCUs. But in this case, we want to minimize the number of components and rather have one more powerful processor that can do this. So that's for the motor control. There'll be a battery that will be powering both these processors. So we'll have 2 processors. One is for the flight control, and the second part will be the computer vision and AI processor. The computer vision AI processor will be getting information from the 6 cameras. So as I mentioned, it'll be front, back, left, right, top, bottom cameras, and based on the information it gets from the camera, it'll be able to understand depth. And once it understands depth, it'll be able to understand, and you set a high-level mission. The computer vision algorithm will do all the flight planning. It will do all the depth detection, and it'll send the signal to the flight controller, to basically move the motors so the quadcopter moves. That's really what's really happening under the hood. You can control the system wirelessly through radio, either through Bluetooth or long-range Bluetooth, maybe even through LTE. Basically, you can call the mobile phone and call the drone and say, perform this particular mission. For example, monitor a forest. So the whole idea is also to make this drone, be by itself. For example, you just want it to, be mounted on a tree. Let it be in the tree, and let it perform its research on the tree. We want it to be autonomous, but we also want it to be, have its own autonomy, to have its own independence as well. And that's the second core feature of what we want this drone to do, is the ability for it to be in a location as long as it can be, and we'll create a system where the battery can be charged. And that's it can be pretty simple if you put a small little solar panel on the top of a tree, and you can basically charge the battery, and that can charge the drones. The computer vision algorithm will also have the capability of controlling a servo motor, which and the servo motor is basically, if you really look at this, the front part over here, you want to control it through a servo motor, and one of those cameras will be an infrared camera. The other one could be a high resolution camera, where you want to capture much higher resolution, way beyond what is necessary for navigation and depth detection. So that's what this particular part of the block diagram does. It is for the AI computer vision processor to have to control the servo motors, so that you can and control the servo motors in terms of stability. You don't want the images to be captured that are constantly shaky or distorted. You want them to be stable, so it's easy. It's nice to view them, and it's not fuzzy. It's not blurry. You'll also have infrared cameras, and these are optional cameras depending on the mission, depending on the use case. You can swap this part based on the mission that and the sensors that the types of imaging or the type of mission you want. You can optimize it based on you can select the camera based on the missions based on the mission parameters. Yeah. That's pretty much it. This is the high level block level diagram. Now, as you can see, there's a lot of you're dealing with computer vision in one end, and you're also dealing with flight control on the other end, and then your IMU sensing will be the sensor reading will be fed to both the flight control and the computer vision, because you want to use this data to basically control the servo motor, to also understand the orientation of the camera, and you can basically say, hey, what, the drone is tilted at 30 degrees, so we're capturing the images at 30 degrees. What would the image look like when it's 0 degrees? So you want the computer to also know the angle at which it's capturing these images, and that's the reason why you want to feed the sensor, this IMU data, to both the computer vision and the AI processor. Sorry, the AI processor and the flight control processor. Mostly a microcontroller over here. The radio wireless, as I mentioned, will also be feeding to both, because sometimes you might want to have full control of the flight controller and completely omit the computer vision and take complete charge of it. This might be an emergency case, or you realize that the computer vision algorithm or the camera is very dusty and it's not able to perform certain computation, or it's damaged. You rather have full control over the flight controller. So you want to basically send signals to the flight controller or to the computer vision, and both. And in most cases, if the drone is flying properly, you generally will just send the information to the computer vision. It'll compute based on the depth and create a navigation and flight plan, and then send the signals to the flight controller. But in certain cases where you want to have full control over the drone, this is where you want to have the radio control talking to the flight controller as well. And you also there's also, it's bidirectional, because you want to get the sensor reading, you want to get the motor speed reading, you want to get the camera readings and the camera data. So you also want to make sure it's bidirectional, so that the data is also transmitted back to the mission control unit. So this is the high level concept of what the Boxy drone in this particular case is all about. But nevertheless, to make this particular drone work, especially autonomously, that's the kind of that's the high level block diagram that is needed. All right, so if you like this video, I highly recommend you to subscribe or like this video. And until next time, thank you.